All right, so we're going to finish up the test study guide for Unit 7. So hopefully you've watched the first video where we did 1 through 28. Now we're going to work on the rest. So now we've got to figure out the types of problems. Remember, we have 4 types of problems. And one of the types of problems is where you have a single logarithm equal to a single logarithm. In this case, you just set values equal to each other. So we've got a single logarithm on this side equal to a single logarithm on this side. We're just going to set this equal to this. The logs go away. 5x plus 7 equals 2x plus 31. Subtract 2x, I get 3x equals 24. Subtract 7, 31 minus 7 is 24. Divide by 3, x equals 8. We're going to do the same thing here. You've got a logarithm, a natural logarithm equal to a natural logarithm. Now this one, you've got p squared. So you're going to do p squared minus p equals 6p plus 18. Now, since this is a quadratic, you're going to have to set it equal to 0 and then factor. So I'm going to subtract 6p and subtract 18. Now I've got a trinomial. What two numbers are going to multiply to give me negative 18 and add to give me negative 7. And now I can factor p minus 9, p plus 2. So then when you're here, you're just going to then solve for p. So you get p minus 9 equals 0. P plus 2 equals 0, because of course you're going to have 2 answers. P equals 9. P equals negative 2. I need to double check and make sure that neither one of those is going to create a negative logarithm, and I'm good on both. So those are my 2 answers. Alright, so now the next type of problems we have are the type where you have a logarithm, but there's not just one, there's 2. We need to create that into 1 log equals 1 log. So we've got 2 logs here. We're going to have to condense first. And so that we can get, we're going to condense to get a log equal to a log. So right now I've got 2 logs on this side and 1 log over here. So in order to condense, I'm using my properties, which we did up here in this condense section, right? So I'm going to come back down here and I'm going to use my properties. I'm going to move this 1/2. So I've got log 8 36 to the 1/2, since there is a plus sign right there, plus using the product rule is multiplication. So that's going to be times 3k plus 7 equals, and I still have my logarithm. You cannot get rid of that log too quickly. So I know that 36 to the 1/2 power is the same thing as the square root of 36. The square root of 36 is 6. So I get log base 8 of 6, 3k plus 7 equals log base 8 of 132. Now I've got a log equal to another log. So now I'm set, and I can now set this equal to that. And I can drop the logs and just equal those out. So 6 times 3k is going to give me 18k plus 42 equals 132. Now I can solve for k. Subtract 42 from each side. I'm going to get 90. Divide by 18. And I get k equals 90 divided by 18. I should know that. But 90 divided by 18, 5. Again, I'm just going to do a quick check. Make sure that 5 can go in there and not make it a negative or a 0. And I'm good to go. All right. So that's going to be the same with this one. I want to have you guys do that one on your own. Now the difference though is this is going to have to be squared. So you're going to get log y plus 5 squared equals log 20 divided by 5. This you're going to have to FOIL, right? So see if you can work that out. Pause the video and then see if you can do that one before I do it. Pause the video. All right, so now you've got y squared plus 5, or y plus 5 squared is going to be y plus 5 equals 4. You're going to get y squared plus 5y plus 5y plus 25 equals 4. Now you're going to get y squared plus 10y plus 25 equals 4. Subtract 4 because now I've got a quadratic that I need to set equal to 0. Subtract 4 from each side. And then I can factor what two numbers are going to multiply to give me 21, add to give me 10, that's going to be 7 and 3, y plus 7, y plus 3 equals 0, y plus 7 equals 0, which is going to be y equals negative 7, y plus 3 equals 0, which is going to be y equals negative 3. Now I need to double check. Negative 7 is going to make this negative. But then it's going to be squared, so it'll be positive, so that's okay. Both answers will work. Moving on. So now we have the third type of problem, which is a logarithm equal to a number, right? So when I have this, when the answer is the variable, and when I mean the answer, I mean that term right there, then you need to convert to an exponential equation. So I'm going to take this, I've got a logarithm equal to a number. When I turn this into an exponential equation, it's going to be 2 raised to the 7th power equals 9m plus 2. And look, now I can solve that easily. 2 to the 7th power is 128 equals 9m plus 2. Subtract 2. Divided by 9. And I get 14 equals m. Alright. That would be the same thing here. The only difference is that now you need to get your logarithm isolated. So this 5 is kind of standing in the way. So you want to isolate the logarithm first before you turn it into a exponential equation. So when I divide by 5 by both sides, I'm going to be left with the natural log of 2a minus 1 equals 15 divided by 5 is 3. Right, do you see that? I basically divided this by 5, divided that by 5. Those two 5's cancel out, and I'm left with just the natural log of 2a minus 1. Now I have a log equal to a number. What's the base? E. So I've got e raised to the third power 2a minus 1, and remember e is a number. I can take the calculator and go into second, right here, second here. Oh, I can't get this on the screen very well. Raised to the third power, and that's going to give me 20.086. I'm rounding it to 3 numbers. 2a minus 1. Now I can add 1 to both sides. Add 1 here, add 1 there. 21.086. And then divide that by 2. 10.543. I'm rounding that up because of the 7. And there you go. All right. Now, same type of thing. We've already done this, but you know, these are exponential equations. It's kind of a blast from the past. They do not have the same base. I need to create the same base. Create same base if it's not already the same. So I've got 64 and this base is 4. So I know that 64 is 4 to the third power. So if I take that 64, 4 to the third power, then I multiply x plus 7 equals 4, 5x minus 3. Now I have the same base, so I can set these equal to each other. Do not set those equal to each other until you have the same base. So I get 3x plus, and I'm going to distribute this 3, 21, 5x minus 3. Now I solve for x. I'm going to subtract 3x to go this way so that I keep it positive. Minus 3x. 21 equals 2x minus 3. Add 3. 24 equals 2x. Divide by 2. X is going to equal 12. And I can pop that back in here real quick. 12 plus 7 is 19 times 3 is, goodness gracious, I'm having a hard time. 19 times 3 is 57. 12 times 5 minus 3, that should be 57. I've checked my answer. All right. Now, how do we find the same base here? This is going to be 3 squared. 9 is 3 squared. W minus 8. 1/27. Well, we know 27 is 3 cubed, and to get it in that denominator of the fraction, we make it negative. Do you remember that? So now I've got 3 to the negative 3 times that 2w. I'm going to multiply that out. 3, 2w minus 2 times negative 8 is 16. 3 to the negative 6w, but now I've got the same base. So now I can just set these equal to each other. So I get 2w minus 16 equals negative 6w. If I subtract 2w, I'm going to be left with negative 16 equals negative 8w. Divide by negative 8. And I get 2. Alright? So that is where you've got them with where you can create the same base. Now, these, I cannot create the same base. No same base. And how do I know that? Well, I know that by looking at the numbers. 48 is not a perfect square or a perfect cube. So there's no way I can create a perfect square or a perfect cube with 48. So what do we do? When they know the same base and you can't create it, you've got to change it to a logarithm. Okay? If you cannot create the same base, you've got to change it to a logarithm. There's no way I can possibly change that to the same base. So I'm going to create a logarithm. I'm going to create log base 8 of 48 equals n minus 5. Now I've got the log base 8 of a number. I'm going to use my change of base. So I do my log of 48 divided by log of 8 equals n minus 5. Plug that into my calculator. Log of 48 divided by log of 8. I get 1.862 equals n minus 5. Add 5 to both sides. 6.862 equals n. So that's how you do those. You have to be able to identify the difference between when you can create the same base and when you cannot. And what do I do with this mess? Before I do anything, do you remember how I told you to circle your number with your exponent? Now we need to get everything on the other side. So you're going to isolate your exponent. Isolate the exponent first. So in order to do that, I'm going to add 11 to both sides. And I'm going to be left with 2 times 3 to the 4y equals 72. Now to get rid of this 2, I'm multiplying here. So I need to divide by 2. And I get 3 to the 4y equals 72 divided by 2 is 36. And now I've got a problem very similar to this one here. I've got a base, I've got an exponent in my, variable in my exponent, and an answer. So here I can take the logarithm and use my change of base. Log of 3 of 26, log base 3 of 26 is going to equal my 4y. Use my change of base formula. Log 36 divided by log 3. 3.262 equals 4y. Divide both sides by 4. 0.8115. Alright, this 4 makes that a 5, even though that's 6. Just don't overthink it. And there you have it. And then these are the same with natural logs. Same type of idea. Alright. Pause the video and then I will just write the answers down. All right, there are a couple of steps. Hopefully you did more than these. This is not okay for your test. You would not be able to do that in your head. Those are just to get you along. All right, check your answers. The last little bit, just keep in mind that your exponential growth formula is y equals A, which is your initial amount, 1 plus the rate plus t. This is your growth rate, because remember the b has to be bigger than 1. Your decay rate, you're going to subtract the rate because it has to be less than 1, and compound interest. Your principal, 1 plus your rate divided by the number of times it's compounded. And then your year. So in here, so if you invested $5,000, your initial amount is $5,000. Increase by 2.3. That's going to be 0.023. My model is going to be y equals 5,000. And I am increasing, that's a growth, 1 plus 0.023 to the x power, or to the t. After 15 years, you're going to plug in that 15 and get 7,032.42. That's how much money you would have at the end of the 15 years. Now, if you have a baseball card that's valued at $200, the initial value is $200. Again, it's increasing by 7%. Your rate is 0.07, 7%. We're increasing. So it's going to be y equals 200, 1 plus 0.07 to the x power. 200, 1.07. Now it's saying find it in, it's from 1980 to 2016. Well, how many years is that? 2016 minus 1980. It's going to be 36 years. You put your amount of time up there. Your baseball card would be worth $2,284.79. All right, guys. Hopefully that's helpful. Take care.